In this tutorial, we will see how to change allocation penalties and how changing these penalties impacts water allocation in a water resource system model. We will use the synthetic water resource system model shown on the screen now. The model runs from January 2021 to December 2021 and has a monthly time step. The model contains two water inflow nodes. Each of the two inflow nodes is populated with a monthly inflow profile. The model also contains three water abstraction nodes: irrigation, municipal, and industrial. The irrigation water abstraction target is 65 million meter cube per day. The municipal water abstraction target is 130 million meter cube per day. The industrial water abstraction target is 50 million meter cube per day. The model also contains a storage reservoir to store excess water during high flows. Each of the three water abstraction nodes is populated with a water allocation penalty. These penalties determine water allocation priorities at each time step. Assigning a negative penalty increases the water allocation priority. For example, the irrigation water abstraction node has a higher water allocation priority than the municipal water abstraction node. This is because the allocation penalty of the irrigation node is -20, whereas the allocation penalty of the municipal node is -10. The industrial node has the lowest water allocation priority because its allocation penalty is -5. Now let us change the allocation penalty of the industrial water abstraction node and see how that affects the simulation results. Create a new scenario by cloning the baseline scenario. You can give the new scenario any name. In the new scenario, change the allocation penalty of the industrial water abstraction node from -5 to -30. This means the industrial water abstraction node will have the highest water allocation priority in this scenario. Run the baseline scenario and the new scenario that we created. Let us now examine the difference between the results of the two scenarios. Create a time series plot of the water abstraction at the industrial node in the two scenarios. The orange line shows that the water abstraction target of the industrial node has always been met under the second scenario. This is because the second scenario prioritizes industrial water supply. The increase in industrial water supply comes at the expense of irrigation and municipal water supplies, as shown by the simulation results.